this AC, what they doing today? Eh? So I don't know why this. No, you transfer to the. Okay. Transfer to. So if you can transfer here, and then I'll give you cash. So you can give me for cash. Because transfer is extra load. Stress for me. If you 5,000 and that bank, if it's not the bank, they'll charge 100 and something. I went to First Bank to withdraw 5,000 and they say I have to pay 107,000. I don't understand. Hello? I think we can unmute firstly ask questions so far. If there are things you don't understand, because I will be ending my class with you today, and Prof is going to start up with respect to her schedule. So if there's anything you don't understand, you want us to talk about, the floor is open for you. But for this class, what I want us to dwell on is the synthesis. On the last, you can actually do it, but I just want to give us some things that might look so insignificant, but very important. Okay, you can see now in this synthesis we are using 2 moles of magnesium added, and we are going to use Wolff's reaction. With Wolff's reaction, we are going to form a spalene. Then when this spalene is formed, remember our own target is the last product, okay, which is cholesterol. So we're using our spalene to synthesize cholesterol. So that, but how do we get the spalene? Spalene is produced from farnesene bromide. Then with under spalene, under oxidation in the presence of acid. Guys, look at the formula for acid. Acid is because instead of normal acid, it's going to have 3 oxygen. So you have like benzoic acid. When you have extra oxygen, it becomes acid. Okay. Under oxidation, we are going to have an intermediate, right? The intermediate is what will be undergoing that same oxidation until we form lanestrol, okay, which also reacts to form cholesterol. So if you look at the reaction, what is actually happening from oxidation reaction is oxidation with the cholesterol. So if you realize what is happening, it causes the close of the ring. From the first one, we have an oxidation epoxide form. The oxidation brought about epoxide, and the bond of epoxide is going to break out. That's why we have the phenolic or hydroxy functional group. And you can see what is happening is that the double bond is one that is coming out to close the ring, virtually the double bond. So virtually what you are doing is closing of the ring by the double bond, and close after the oxidation, we're going to break the bond of the oxide to form hydroxy functional group. So if we look at from lanestrol to cholesterol, what happened? We can understand that what is happening is that the ethyl on the terminal ring that bear the hydroxy group is what will cleave out. On the first carbon is going to be saturated for us to form our cholesterol. So virtually that is what happened. Cholesterol is saturated. Remember, lanestrol is unsaturated. When cholesterol is saturated version, all the unsaturation is being taken care of. So virtually you can talk about that a sort of hydrogenation and cleavage of that bond. Okay. There is 1, 2 shifts of methyl group 8 to C14. Lanestrol. So shifts of methyl and the saturation of the double bonds. So can you ask questions generally on this section of the material presented to you? Remember in this that we are talking about monoterpenoid. We're talking about monoterpenoid. And we'll talk about monoterpene and monoterpenoid, the difference between them. Okay, it's just oxygenated. And we'll talk about some examples. And we'll talk about the cyclic, bicyclic. We'll also talk about the synthesis of beta-catenin. I'll talk about how we're going to use, how we're going to form peroxy, pyrometallic acid, And then we're now talking about anything you needed to understand, you didn't understand. So if you ask about synthesis of cholesterol, you have to start from synthesis of squalene using whose reaction? Okay, with reactant of an active So that is what brought about the plus cyclization to form. Remember everything. Now all this is happening in nature, okay, or naturally in plants. That's why they call it biosynthesis. Synthesis that occur naturally in plants and humans' body. Okay, so ask your question. The floor is open for you. Whatever we've done on this topic, ask, and Prof will be there with you. Maybe on Wednesday, I'm going to update her that we are done. Don't forget the precursors of monotapenoid, sesquiterpenoid. Don't also forget the classifications. The classifications are important. You have to know the classification. And how do I synthesize my camphor from alpha pinene? We talked about that. Okay. So just know, like I said, examples of each of the class, the monoterpene, sesqui, and di. The examples, cyclic is cyclic, you might be cyclic, you might be acyclic. You just make sure you have at least knowledge of two name and structures. Always practicing. Okay, we're talking about the basic skeleton of all terpenoids or precursor of terpenoids are mevalonic acid pathway. That's the pathway for synthesis. So let me ask your question at this stage. Ibitioye. Is there any question? Victoria? Akimboboye. Hey, Jehovah. I cannot spoil on a name. No question. Because if anybody will not get A for this 844, the person is my number one enemy. So make Sile. Emmanuel Popola. Kosile. So how many attendants do you have today? Right?
I'm with you, ma. I'm with you, ma. Ma, Emmanuel Popola is with you.
You don't come to class, so.
No, I'm with you, ma. It's the network.
How will I know? Everybody unmute
I'm with you. I can hear you.
Let me know people that are. At least I will know what is happening at your background. Unmute everybody. Everybody must ask question. Oh. You're not asking question.
Good morning, ma.
What is the precursor for synthesis of steroid, of cholesterol? You guys are not talking. What's the precursor for synthesis of cholesterol? Who can answer my question? What's the precursor for synthesis of Bukola and Bimbala is not in class today. She just log on and waka. Emmanuel Popola is not in class today.
I'm in class, ma.
Don't put your foot in.
I'm in class, ma. Emmanuel Popola is in class, ma.
Wahab Olaleko. You're not in class soon. Nobody, people should not mute yourself for now. Don't mute yourself. So nobody can answer my question.
No,
What is the precursor for cholesterol?
Pauline.
You okay? If you have gotten this, Babi. Okay. So now, when else are you having class? I need to talk to Prof.
Please, I want to ask a question, ma.
Better. That's what I want.
Yes, ma. Ma, please, just to be sure. Ma, is mevalonic pathway the starting material for the all the basic material for
tapinoid? Yes.
Okay.
Ask question. Ask a question now. Be sure. Be very sure. Ask your question. Is that the last? Any other question? Everybody can mute yourself. Let me mute everybody. Then, if you want to ask question, you mute and ask. I want to give us grace of 5 minutes before I end the class. So I'm done with you guys. Professor Shiku, please. Since the project supervision has been shared, make sure you contact your project supervisor on time so that you don't give yourself unnecessary tension. Start your project now, even if not for anything, you can start literature review. You can do that one at the comfort of your house. So make sure you liaise with your supervisor so that you know where the line you're going and start planning towards that by doing the preliminary introduction, review, and everything. So that when the time comes, and they're talking about deadline now, you will not be, nobody will be running after you. There is no time. Okay. So in the absence of that, I think you guys are good to go, right? If you still have questions, well, if you don't ask questions, I don't think I'll have time to listen to your question after here, because I'm giving you the opportunity. I think I told us before now that if you reach and ask questions so that we can summarize this class today. I can hear you.
Yes, ma. Ma, you said you were going to explain reactions of abiotic acid to us today, ma.
Okay, I'll talk about it. Yes, I think the reaction I've not really looked into it because what is in the slide is not what that's. I'll get back to us on that on a private arrangement But let me talk to Prof first. This is the slide that Prof gave to us. So I'll speak there before I go ahead and do any adjustments on the slide that I gave out. For the interior, just get familiarize yourself with camphor in reaction. That one is very, very important. When you're using 1 mole or 2 mole of the acid, just know the products. Also know about retinol. I talked about your retinol. You should know retinol and oxidation of retinol to retinal and to retinoic acid. Also understand that very well, very, very important. Okay, you have to understand that. In a reaction of abiotic acid, I don't think you need to know every reaction. Just familiarize yourself in any one or two that is familiar with you. Any of them that is familiar with you. Don't need to stress yourself about the reaction of abiotic acid. Just now, when you go back to the slide of abiotic acid reaction, let's see how far we can do justice to that. So I don't come back again until you stand for your exams. Victoria, I want to see you so we can discuss what you're planning to do in your projects.
Yes, ma'am. I'll see you after the class. I'm in school.
Okay, fine. So now, if you look at the first one of using phosphochloride. Now, if you look at that, you know that where the reaction is occurring is at that terminal place. Now, that terminal end, we have CH2OH. So that's where that's where the reaction is occurring, and that's the extension of the ring. Okay, and when you're going to use selenin is like the hydrogenation. So that's why we have aromatic ring all the way. Okay, so whenever you're looking at this, you're looking at what with the reactant, what can we get? Now, if you look at when I'm adding sodium metal and ethanol, that I'm talking about 2.303 structure. You realize that the ester functional group was what was shown to alcohol, without talking about the reaction that is undergoing its hydrolysis. When ester moves to alcohol. So that's what you're going to be looking at. What is happening where and how and why. Whenever you put the reagent, there's something that is happening. And if you look at when I'm in my structure 2.154 or something, you can see oxidation and reduction. The compound can undergo oxidation. When it undergo oxidation, you see the hydroxyl end turns to carboxylic acid. That's the functional. That's where the reaction is occurring. If under alkaline permanganate, what is happening? You are forming a ketone. Okay, forming a ketone. The carboxylic acid become a ketone, and the alcohol. Okay, the alcohol bond has been under alkaline permanganate. Look at the compound that is undergoing alkaline. The same compound. I think if you look at this reaction, it has to follow it sequentially, following the movement of the arrow. Now, if you look at after adding selenium, we're going to selenium and PDC. That's what hydrogenation. This is hydrogenation. This is dehydrogenation. This is a chromic acid is forming is oxidation. From oxidation, will undergo alkaline being reduction. From reduction, we oxidize again. So this reaction is how we're going to learn this particular reaction is when you bring out a reactant, you follow the reagent. Okay, because the reaction is somehow that it cannot talk about the product until you talk about the reactant and the reagent. So it's like a circle reaction when it comes to this abiotic acid reaction. So what I will advise you to do is go back. What is the structure of abiotic acid? Let's go back to the structure of abiotic acid. So you know where you're starting from as your starting material. This is abiotic acid. Abiotic acid has carboxylic functional group. Okay? Acid. So knowing the structure of this carboxylic acid, you understand where is this carboxylic acid in this structure. So you understand where your reaction is coming from. If you look at 2.19, structure 2.19 is actually abiotic acid. So understanding that 2.191 is abiotic acid, then follow it from there. Then be able to know about 2 or 3 reactions of this abiotic acid. Right? Now, even if I want to go my left or my right, that's what happens. If I'm going my right, you can see I'm adding silicon, selenium, platinum, and carbon. Platinum and carbon are like catalysts. Then I'm going to form like all the compound is dehydrogenated. So I'm going to form aromatic rings. So when under chromic acid, I'm going to oxidize this ring. Okay, the oxidation of this ring makes it possible that double bond at the second ring was one that breaks out and form ketone. Remember, whenever you're doing oxidation, the middle carbon that has one hydrogen becomes ketone, right? But if it's terminal carbon with one hydrogen, it becomes aldehyde. So that's why we're having ketone. That ketone, which undergoes oxidation again, under alkaline permanganate, the bond is clipped. So when that ketone functional bond is clipped, and you can see the carbon, the terminal ring becomes carboxylic acid. And when I do further oxidation, I'm going to form carboxylic acid in both ends of the first carbon, first ring and the last ring. So virtually that's how to learn this. So trace from 2.191, then just know 2 or 3 reactions of abiotic acid. I think that's fine. So that's your question. So I think I've done justice what I want to do in my abiotic acid. So look at the abiotic acid and learn any of the 2 reactions or 3 reactions. That's any other question? Who asked the question? Do we still have any question in the house? Emmanuel, say fast. Atanda, you're fine, right?
Yes, ma'am. Thank you very much.
Okay, any other question? See, if you guys go and lay your hands on past questions, this particular 844 is a very easy course, it's not difficult. So lay your hands on the past questions, okay? And if anything, there's something you see that the dots are not connecting, then you can talk to me on private chat, or you can come around if you're in school, talk about it. So that's how to pass exam. Know the mode of asking question and know what your lecturer is expecting. It's even good to go through past questions before you start reading. But when you start reading, some of the questions that you be able to come across unconsciously, you're going to see when you're seeing the answer, you can be able to relate. Okay? Okay.
All
thank
right,
you very much. Yeah, thank you, everyone. Sorry for
Ma.
taking this class later than supposed. So, in the absence of any other question, Professor Sheku will see you, will take over, and maybe we'll see you on the exam day. But I think we might end up having a test if possible. If not, we're going to make use of our CA. So if you've not submitted your CA, at least we've done 2. So the TA for today is synthesis of cholesterol. Okay, from farnesyl bromide. Show the detailed synthesis of cholesterol from farnesyl bromide. So that assignment is due by tomorrow night, 11:59 tomorrow. Thank you.
Thank you, ma'am.
Thank you.
Bye for now.
Thank you, ma.
Bye, everyone.
Yeah, bye, ma.